Okay, welcome to another video recording a work solution to a AQA A-level physics question. This time it's a mechanics question about an air gun pellet. Please pause the video and read the question if you haven't already. Okay, so we're given quite a bit of information. This string is inextensible, so it doesn't stretch. The thing it's attached to is rigid, so it doesn't move. Pellet comes in, hits this block, gets embedded in the block, and the block rises up. Its centre of mass rises by this value. The pellet has a mass of 8.8 grams. The block has a mass of 450 grams. Okay, so this is all the information we're given, and we're asked to determine the speed of the pellet when it strikes the block. So straight away, this brings to mind to me conservation of momentum. So if I try starting with conservation of momentum, you'll see later that I have to get a bit more involved, and it's a 4-mark question, so we kind of expect it to be quite an involved question. But if I write down the momentum before, should be equal to the momentum after, m after, right? So what have we got beforehand? In the before picture, we have a block suspended and a pellet coming shooting in to smack into it. In the after picture, we've got a block with a pellet embedded inside it that is flying upwards, right? So that's the before and after pictures. Okay, pellet moving, block stationary, pellet and block moving. So we have two momentums to consider before, so that's mv for the pellet plus the mv for the block, and after we only have one momentum to consider. Right. So now we have to be careful about units. The momentum unit is kilogram meters per second, right? So the block is in grams, so I should put down 8.8 times 10 to the minus 3 to convert it into kilograms, times by the velocity of the pellet, which is what we're trying to work out. This is the value we're trying to find, plus the momentum of the block. Well, the block has a mass of 450 grams, which is actually 0.45 kilograms, times a velocity of 0 at the beginning. Then we've got the pellet and the block become, well, the pellet's embedded in the block, so they become one object. So now I have to add the mass of the pellet and the block together for the mass of the situation afterwards. So that becomes 0.4588 kilograms times by the velocity of the block after, which is something I actually don't know at the moment. So it appears that I have two unknowns, but I have been given this extra piece of information in the question. And by thinking about conservation of energy, so this is thinking about conservation of energy, I might be able to get this velocity. So whatever kinetic energy the block had here, it has all been converted into gravitational potential energy here. So if I know how much GPE we had, GPE, I can also know how much kinetic energy we've got. And I can calculate the GPE. So GPE is mass times gravity times height. KE is half mv squared. The masses are going to be the same because the pellet and block are embedded in each other. So I can cancel the mass from both sides. I can multiply both sides by 2, which gets rid of the half. It gets me 2gh equals v squared. And taking the root of both sides cancels this. So I'm left with v equals root 2gh. Right? v equals root 2gh. So I can sub this in for this value of v. Okay, so rewriting this line again and simplifying, you can see 0 times that cancels out. So I've just got 8.8 times 10 to the minus 3 times the v I'm looking for equals 0.4588 times the root 2gh, which is obviously going to be root 2gh is going to be 2 times 9.81 gravity on Earth times the height that this block raised, which is 0.63. A little bit messy, you can't quite see there, but that's what I've written. Okay. Now dividing both sides by 8.8 times 10 to the minus 3. 8.8 times 10 to the minus 3. bit of a mess, I must admit, but this cancels, and then I can simply go ahead and calculate V, right? So in order to calculate V, I'm doing the mass of the combined block, the block and the pellet combined together, multiplied by root 2GH, divided by 8.8 times 10 to the minus 3, okay? And when I do that, I get a value of 183.29, so V comes out as 183.29 meters per second, and I'll write it to just 3 significant figures, 183. Okay, so it's a lot of work for 4 marks. It's this concept here that you had to realise that you had to do this conservation of energy chunk before you could continue with the momentum part. Okay, so now the wooden block has been replaced by a steel block with the same mass, and the experiment is repeated with an identical pellet, but this time the pellet rebounds. Okay, discuss how the height of the steel block compares with 0.63 meters. Okay, right, so what we're going to think about here is if the pellet rebounds, so the block's here, but this time the pellet comes in with a given momentum and leaves with a given momentum, right? And it leaves with a certain amount of momentum. Now, if it's perfectly elastic, the momentum that it leaves with would be in magnitude identical. But either way, right? If the pellet comes in, embeds, sticks inside this thing, it starts off with a certain momentum, and it slows down to whatever the new velocity of the block is, right? So there's a change in momentum for the pellet. If it bounces off, it's likely that the change in momentum will be higher. So if the change in momentum of the pellet is higher, and the thing that caused that change in momentum is the block will have a greater change in momentum. If the block has a greater change in momentum, then it's going to be moving faster. Right, so basically, as the pellet rebounds, the momentum change of the pellet is doubled. Right, well, it's nearly doubled. We're not entirely sure if it doubles, but because it's gone in with a certain velocity and it's left with a certain velocity, the change in velocity is definitely greater. Okay, so again, the momentum of the block is also doubled. Maybe it'd be better to say increased here, really, rather than doubled, but the mark scheme doesn't condone saying doubled. Okay. Right, since the block is the same mass as the wooden block, its velocity will be higher due to its greater gain in momentum. So because the pellet has slowed down by more, or its velocity has changed by more, it's come in at whatever, let's say it came in at 10 meters per second and left at minus 10 meters per second, its change in velocity would be 20 meters per second. So that means that its change in momentum would be larger as well, which means that the change in momentum of this must be larger. So the block must have gained a greater amount of momentum, meaning a higher velocity. High velocity means greater kinetic energy, therefore the GPE gained would be greater, so the height would be greater. Alright, so that's that part. So now discuss which experiment is likely to give a more accurate value for the velocity of the pellet. Okay, so you're either going to do this with a steel block or with a wooden block. Now if you do it with a steel block, the pellet could come in at, as we've already calculated, 183 meters per second. And if you knew that it did leave at 183 meters per second, then you would know the change in momentum of the pellet and therefore the block. But because when the pellet strikes the block, it deforms and changes shape, and we don't know how much energy went into doing that, we don't know the rebound velocity of the pellet. Right? So some energy will be lost in deforming the pellet. This means that we can't know the change in momentum exactly of the pellet, and therefore not of the block. Whereas in the case of the pellet that gets embedded in the block, we do know the change in momentum of the pellet, because it goes from the velocity that it was going at, 183, to the new velocity of the block at the beginning. So in terms of which is more accurate, using the wooden block would be better. So in the steel block method, energy will be used deforming the pellet. Since there's no way of knowing the rebound velocity of the pellet, the exact change in momentum could not be calculated. This can be calculated in the wooden block method, making it a superior method. Okay, I hope you found this video useful. Thanks for watching. Please comment, like and share.